Okay, the first page of review for solving radical test. I'm going to do it page by page. So here's page 1, simplifying radical expressions. With cube roots, remember your cube root can be negative. So I'm just going to pull the negative out in front and break down 1,000. 1,000 is 1, 2, 3 2s and 3 5s. And then with B's, you can write out 6 B's, but you're grouping them in 3s. So if you take 6 groups and group them in 3, that is 2 groups of 3. So B squared comes outside. And then the same thing with the numbers. Every 3, since it is the cube root, every 3, 1 comes out. Every 3, 1 comes out. So I'm going to put 2 times 5 times B squared. And so then since nothing's left under the radical just goes away. So the cube root sign goes away. So you get negative 10 B squared. That's it. Again, this is cube root 1/3, even though it's written a little different. Remember, the top is your power exponent. All right, exponent. The bottom is your root, EI, or your index. How I like to remember it is EIEIO. Remember, Old MacDonald. Again, I'm going to take the negative out. When you break down 192, you get 6 2s. So I'm going to write it like this and not 6 2s. I'm not going to waste your time. Times 3 times x to the 8th. So 6 2s can group into 3. So I have the negative 5 out front. Every 3, that'd be 2 groups of 3. The 3 can't group, so it'll stay underneath. And if I do the x's, there will be 2 groups of 3. That's 6, 7, 8. So 2 left inside, and that 3 is on the inside. It's a little funny way to write it. 2, 4 times 5 is 20. X squared. Cube root 3x cubed. I said cubed, I meant squared. And there you go. Again, over here, the top is your exponent, the bottom is your index. So this is the 5th root of 32, and you can put the 2 here and square it. I personally don't like that. I like to put, if I know the 5th root of 2, the 5th root of 32, I'll square it afterwards. And I do know the 5th root of 32 because it's 5 2s. So 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is 2, and then I have to square that to get 4. Okay. The square root of a negative number, that is the definition of imaginary. A square root of negative 1 is I. So I'm going to go ahead and take that negative out and make it I. And then we know the square root of 100, it's 10, because 10 times 10 gives me 100. So the square root goes away. I could just done multiplication signs, but that's negative 30I. So we're doing the cube root. Technically, the negative's on the outside. We're not taking the cube root of negative 27. We're taking the cube root of just 27. If you wanted it to be negative 27, I'd have to have those parentheses. But since it's cube root, it doesn't matter because the negative can be on the inside or the outside. But the cube root of 27 is 3, so negative 3. When you're adding like variables, you have to have the same index, so they're both the 5th root, and the same radicand, so the bottom number is the same. And when that's the case, you just add their coefficients. 2 and 4 is 6, and you leave the radicand alone. Don't add the radicand. That's it. Break down 200. Well, I'm going to make this easy on us. 2 times 100, right? Because we know the square root of 100 is 10. Make that a little easy. 32, we just did up here, is 5 2s. So if we do have 5 2s under the radical, 1, 2, 3, 4, 5, all being multiplied together, there's 2 groups of 2, so 4 square root 2. Now we have like terms and we're subtracting, so we get 6 square root of 2. Again, you don't subtract the 2s. Same thing here, break it down. 2 times 3 times 3 minus 3. 2 times 5 times 5. A 3 comes out with the 2, multiply. A 5 comes out with the 3, so 15 square root of 2. 6 minus 15 is negative 9 square root of 2. Some people wrote this in exponential form with a compound like 3 to the 1/2, 3 to the 1/3, and then combined like terms. I just want you to know in this one that you can't multiply these together since this has an index of 2 and that has an index of 3. That is the simplest form. So your answer is the same thing. Yes, you can get it under one radical and it'd be like the 6th root of 2 or something like that. I don't care about that. With multiplying radicals, you multiply what's outside together and get 6. You multiply what's inside together and get 48. But then you have to simplify again. So 48 is 4 2's. And some of you have to do the tree every single time. I have my answer sheet right next to me. I already worked out. So I'm not going to waste your time trying to break down 48. So every 4, since the index is 4, 1 comes out. So 4 times 6 is 24. Oh, I did it again. That's wrong. Sorry. Every 4, 1 comes out. So only 1, 2 is coming out. So that's the 12th. 12. 6 times 2 is 12. Duh. 4th root of 3. 12, 4th root of 3. Final answer. Hesitate. All right, we have the square root of 5 times the square root of 20. You can multiply them first and get the square root of 100. And we know the square root of 100 is 10. When you know the square root, that means your head is already doing 10 times 10 is 100. Don't leave it under the radical. The square root of 5x is being distributed into negative 5 square root 6x plus 2x. So when I multiply this term in, the 5x is on the inside and the 6x is on the inside. You cannot multiply the negative 5 to that. So negative 5 is going to be on the outside. On the inside is 30x squared. 2x is on the outside. 5x is on the inside. They cannot be multiplied. They'll just sit next to each other. And then you can break this one down. 30 is 3 and 10. And 10 is 2 and 5. So you can't break the numbers down, but since you have two x's, an x can come out. So negative 5x square root 30. And then there was nothing on this one, so I'll just bring it down. Make sure everything's under the radical. And there is your answer. Foiling this, because a binomial, 2 terms, times a binomial, 2 terms. That's different from here because this is 1 term times 2 terms. So the 2 is going to get multiplied to both of the other ones. So 2 times 4 is 8. 2 times negative 7 square root of 3. The 2's on the outside, the 7's on the outside, so that'll be negative 14 square root of 3. Switch colors on you. Then square root of 3 goes to both. Again, the 4's on the outside, so it's going to stay on the outside. The 7's on the outside, negative 7, and then that'll be square root of 9. Combine like terms. So 8 minus 10 square root 3 minus 7 square root of 9 is 3. So it's 8 minus 10 square root 3 minus 21. And then 8 minus 21 is negative 13 minus 10 square root 3. There's your answer. If you are dividing and they're both the same radical, they're both 4th root, you can just simplify that. 324 divided by 4 is 81. The 4th root of 81. 81 is 9 times 9, and 9s are a bunch of 3s, so 4 3s. So it's just 3. Way simpler than all that craziness. Keep going, keep going. They're both 1/2, so it's like taking the square root of the whole fraction. And then we're going to go ahead and divide these. So 112 divided by 7 is 16. When you divide like bases, you subtract their exponents. So that's 3, and that's 12 minus 3 is 9. We're taking the square root, so every 2, 1 comes out. The square root of 16 is 4. 1a will come out. 1 will be left in. Offline. Continue working. I wonder how that's going to affect my video. B to the 9th. So 8 b's There's 4 groups, and that leaves 1A on the inside, 1B on the inside. So just to make sure, 2 B's, 1B would be 3B, 8 B's, 1B would be 9B. So there's our answer. This is rationalizing. You can't leave a square root in the bottom. So to get rid of the square root in the bottom, I'm going to multiply the top and the bottom by that. So I'll get 15 square root 5 over the square root of 25. The square root of 25 is just 5. So 15 square root 5 over 5. 15 and 5 are both outside of the radical, so they can simplify. And then I have nothing else to simplify. Here on 16, I only had one term that had a square root on the bottom. On 17, I'll have one term that's a square root at the bottom. But if I just multiply by the square root of 2, it gets stuck with the 5, and I'd still have a radical in the bottom. So that's why when binomials are in the denominator, I'm going to zoom in a little bit on this one. I guess I could have zoomed in a long time ago. Sorry. You have to multiply by the complex conjugate. So the complex conjugate is the opposite sign of the second term. So the middle term changes signs. The 2 is going to get distributed in. So we get 10 minus 6 square root 2. And then the bottom we have to FOIL just like we did up here on number 13. So I can do the same colors I did on 13. 5 times 5 is 25. 5 times negative 3 is negative 15 square root 2. And then 3 square root of 2 times 5 is positive 15 square root of 2. When you're multiplying by the complex conjugate, this should always happen. One should be negative middle term, one should be positive middle term. That's why they always cancel out. 3, same exact term, so that'd be negative 9 square root 4. And that will always simplify, so there's no radical left in the bottom. So we have 10 minus 6 square root 2. 25 minus 9, and then square root of 4 is 2. So 9 times 2 is 18. So I get 10 minus 6 square root 2 over 7. And then you always need to check if all of your terms are divisible by the same thing. Those 3 would simplify. And that square root of 2 doesn't have to have the same common factor. But 10 and 6 are both even, but so they have a factor of 2 in common, but 7 does not. So that is your final answer. And you'll see later on we do simplify some of those. The last 2 on these are graphing and kind of make more sense in the next video. So I'm going to do that in the next video.